All right, welcome back to the R Bootcamp series. We are working through Bootcamp 1, Module 4, and that is programming in R. So we, in the last video, went through functions and conditional statements. And in this video, we're going to go through iteration. So we're going to start here in the website. We can think of functions like we did in the last video as kind of training a computer. All of this programming, boot camp is about talking to a computer. How do we get a computer to do the things we want it to do? Functions are like training a computer. So we tell a computer how to do something, and then the computer knows how to do it. For, say, you're telling a computer how to take a vector, any vector, and take the sum of all the elements of the vector and then divide it by the length and say, now computer, that is how you calculate the mean. Now, if I define this function, take any input vector, do that thing, the algorithm that you want it to do, and then return something called the mean, then the computer knows how to do it, right? And so you've basically trained the computer to do something that it didn't otherwise know how to do. All right. Conditional statements we went through as well. That's simply a really useful construct for algorithms in general, because sometimes in algorithms there's this logical branch, a fork, that we have to say, if something is true, then you do this thing. If another thing, if that thing is false, do another thing. Or if another, if another test is true, then do something else. So that's just a useful construct for generating algorithms, for telling a computer what to do. Oftentimes we'll put conditional statements right into our functions. As we're training a computer to do something, we might use conditional statements or conditional logic in that. So that's what we've gone through already. We're going to talk about iteration in today's video. Iteration is more like a drill sergeant or something, where we're telling a computer to do 100 push-ups or something. So we're basically just getting the computer to do the same thing over and over and over again. Computers are super good at iterating and doing things over and over and over again. We're not mean by doing that, because a computer loves to do things over and over and over again. So iteration is a fundamental aspect of programming for any programming language. And every programming language has a little bit of a different syntax. They're very similar. Oftentimes they're called for loops or do loops or while loops. There's a whole bunch of different constructs. They're all doing the same thing. They're all telling a computer to do the same task over and over and over and over again. All right, so that's where we're going to start. So if you are following along on the website, go to where it says iterating, and otherwise, we're going to go to RStudio and work through for loops in R. So let's pull up RStudio. We're still continuing to work through module 1_4.r. That's the R script for this module. And we're starting where it says for loops. All right. Don't pay attention to the line numbers, because I think I've added a few lines in the previous video. So yours might not match exactly. Your line numbers might not match. All right, so what is a for loop, and how do we use this to get computer to do the same thing over and over and over again? All right, so the syntax is like this. So basically, we use the command for, and then we use parenthesis, and we assign an iteration variable that could be anything. It's a placeholder variable. I could use I could use var, I could use anything. And then you use the term in, all right? And we'll explain what's going on here. But then we have something called an iteration vector. And this could be anything. So I'll call it itervec, all right? And then we use a curly bracket, and within the curly bracket we define everything we want this function. Sorry, we're not doing functions. What we want the computer to iterate over and over again. We want to define the task that the computer is going to do over and over and over again. And so here's where we define task. And obviously our studio is not going to like that because it doesn't like the syntax because this is pseudocode, it's not real code. But let's make it into real code. All right, so first we have to define what our iteration vector is. We can replace that with a real vector. And in this case, we can do 2, 4, and 6. That should be commas. 2, 4, and 6. So we've done that. So now we have to define a task. And we could just define a simple task and just say print whatever the iteration variable is. So what R is going to do here, and this is critical for understanding how to use for loops, is that R is going to define this variable var 3 times. It's going to iterate 3 times in this case because there's 3 elements in this iteration vector. In the first iteration, this variable var is going to be assigned the value 2 because that's the first element in the iteration vector. And then once it finishes, whatever in this, between these 2 curly brackets, it's going to do it again. It's going to now assign var the second value in this iteration vector. Once it finishes the task again, it's going to assign var, the variable var, the third element in the iteration vector. It's going to do this again, and then it's going to realize that we're done going through this iteration vector, and it's going to finish. It's just going to say, okay, we're done, and then the task is over. All right, so let's run that and see what happens. So here it just printed 2, 4, 6. Why did it do that? Because it assigned var the value 2. It printed that value. Then it assigned var the value 4. It printed that value. And then it assigned var the value 6 and printed that value, and then it was done. And then it's like, gives that caret symbol that says, I want more commands now. So it's done. Let's look at some other examples of for loops. And there's a lot of different ways to specify it, but this is the general format. And every for loop in R is going to have that general syntax. Here's another example. For I in 1 to 10, and that's all, when you use that colon, of course, we're talking about every integer between 1 and 10. So that's the iteration vector. That means we're going to iterate this 10 times because the length of this vector is 10. Every time it's going to assign I the value within that iteration vector, and that's the exact same thing we just did, basically. So now it's going to assign, so I is now the iteration variable, and I is assigned 1, 2, 3, 4, all the way to 10. It prints those out, and then it ends. So that's the same thing. Another way to do that, of course, we don't have to use this shorthand. We could use this longhand. I don't know why we would, but it just gives the idea that, you know, whatever's in that iteration vector, it will iterate over. Now, we could omit one of these. So let's say we don't like the number 6, so we're going to get rid of it. And now we're going to print out, and clearly J is assigned all these values, but none of those values are 6, so it never prints out 6. And it only iterates 9 times now. So again, just getting familiar with the syntax. Let's go through. This next way is kind of the most common way. You'll probably see it when you look at other R code, and probably when you start making your own R code. What you do is you assign a variable that stores the number of iterations you want to run. All right. So let's say we assign this variable in iter for the number of iterations, and it is equal to 10. All right. So we're going to want to run 10 iterations. And here I'm going to assign what's called a counter. This you won't see every time, but it's another useful construct for loops. So every time we run through the for loop, every time we iterate, we're going to add 1 to the counter. So let's start the counter at 0. That means we've run the iteration 0 times. Okay. So now we're going to specify a for loop. So we have the iteration variable I, and we're going to assign that to be every member of this vector. And when you say 1 colon and iter, obviously it's just going to flesh out this all the integers between 1 and the number of iterations. So that's what we're essentially doing. This is the way you'll generally see for loops specified in R. So it's really important to know how this one works. And it's just going to assign I the value 1, then I is going to be 2, all the way through 10. When we walk into this for loop, you'll see that every time we iterate, it's going to add 1 to our counter. So in the first loop, counter is going to be 1 because we've added 0 plus 1. In the next loop, counter is going to be 2, and so on and so forth. So that, and then we're going to print out the value of counter. And this is going to give the same result as we've already seen, but this is the syntax that we will most often use for specifying for loops. Although, like I said, the counter isn't always used, but it's another useful thing to see. But this construct, I in 1 colon number of iterations, that construct is what you're going to see a lot. All right, so again, when you look closer, this is what the iteration vector looks like in this common construct here. All right, oftentimes we want to use the iteration variable within our for loop. Sometimes, I can show you this trivial example here, but then we're going to go through a less trivial example, a more interesting example where we do the Fibonacci sequence. But in this case, we're using the iteration vector within the loop. Here, we're going to start a counter at 0, meaning we've run this iteration loop 0 times. Every time we run it, we're going to add not 1 to the counter, but we're going to add I to the counter. So when in the first iteration, I is going to be equal to 1, but then I is going to be equal to 2. So in the second time we iterate through this, I is equal to 2, but counter is going to be equal to 1 plus 2, so I is going to be equal to 3. And if we think it through, the next iteration, I is going to be equal to 3. We add 3 to 3, so count should be assigned the value 6, and so on and so forth. Each time we're going to monitor what count is by printing it out within the for loop. So let's run it. And there we go. So each time we're adding not 1, but we're adding whatever the iteration variable I is assigned every time we run through this loop. And this is what we get. We run through 10 iterations because n iter is equal to 10. And we get this result here. So make sure you understand the basic specification of a for loop before you move on to this next example, which is a little more complex. So if you need to pause the video and just make sure you understand, that's cool. But otherwise, we are going to move on to this example here. We're going to generate the Fibonacci sequence. If you don't know the Fibonacci sequence, it's kind of a fun thing to read about because it kind of comes up in all sorts of aspects of computer science and even biology. Like for some reason, the fronds of a fern somehow, I honestly don't remember how that works, but somehow contains the Fibonacci sequence somewhere in there. So it comes up in all these weird places. So it's kind of a fun sequence to think about in mathematics. But we're just going to generate the Fibonacci sequence, which starts off with basically 0 and 1, and then every subsequent element is the sum of the previous 2. So if you sum up 0 and 1, the next element is 1 as well. And then you sum up 1 and 1, the next element is 2, then you sum up 2 and 1, that's 3, and then you sum up 3, whatever. You sum up the previous 2 elements and you keep going. So we're going to just get the first 10 elements of the Fibonacci sequence. So we're going to set the number of iterations equal to 10. And we'll first set up what's called a storage vector. And this is another really common construct that you're really going to want to wrap your head around because in this case, we're going to set up this vector of all zeros. But then we're going to loop through a for loop and iterate for every member of this vector that is now 0. We're going to replace that with a different value, and that's going to be the values from the Fibonacci sequence in this case. And oftentimes we do this. We set up a storage vector that might be all NAs or all zeros, and then we loop through the same number of times as there are elements in the vector, and we every time, for every loop in the for loop, we add a value to that storage vector, and by the time we're done looping through the whole for loop, we're done filling in the entire storage vector. So that's a really common and really important programming technique. So we assign the number of iterations, we assign a storage vector with number of elements equal to the number of iterations. We assign, for the case of the Fibonacci sequence, what we're going to do is we're going to ignore the initial 0. And we're just going to assign the first two elements to be 1 and 1. And then we're going to start off in the for loop to assign element 3, 4, 5, 6, 7, 8, 9, and 10. All right? And in each of those cases, we're going to assign that value by taking the sum of the previous two values. So let's do this. So first we're going to assign the first element of vector x to be the value 1, and the second element will be the value 1. So now if we look at x, it has all zeros except for the first two elements, which are 1. So what we're going to do in this for loop is we're going to start off with the third element. We're going to assign that to be the sum of the previous two, which should be 2, right? And then we're going to assign the fourth element, which is the sum of the previous two, which will be 3, because this will be assigned 2, so on and so forth. Let's get the computer to do this for us rather than doing this ourselves. Obviously, we could do this ourselves because this is pretty simple math, but say we wanted to get the first 100 elements of the Fibonacci sequence, then we're going to start to really see the value of programming. So let's look at this for loop. So the for loop is going to start with the third element of this vector and go all the way to the end. So the iteration vector will look like this. At first, I will be assigned 3, then 4, and then all the way to 10. Each time, we're going to assign the ith element of the vector. So we're going to start off with 3. So then we're going to assign the third element of the vector to be the sum of the previous two elements. So if I is 3, then we're going to assign the third element of x by taking the I minus 1 element, that is the second element, and the first element added together. Sometimes it's really useful when we're building for loops to kind of simulate in our heads what's actually going to happen in the for loop. We know that the first value of I is going to be 3. So let's actually assign I equals 3. Right now, I doesn't have a value. Oh, well, it does because we assigned a previous for loop. But it doesn't have to have a value in here. If you wanted to debug or work into, or just kind of work in your head through a for loop, it's really useful to assign the iteration variable. So then you can work through the innards of the for loop, the algorithm that you want to iterate, and just make sure everything's working correctly. So it's a really useful thing to do. So I'm going to assign I equals 3. And then you can kind of see what is going to happen. So right now, the third element is 0, the third element of x. But we're going to assign that. Instead of 0, we're going to replace it with the sum of the previous two, which are, so x with the bracket I minus 1 should be the second element, and that's 1. And I minus 2 is the first element, and that's also 1. So if you take 1 plus 1, that's going to be 2. We're going to assign that into the third element of x, and that is going to let us see that the third element of x is now the value 2. All right? So it's kind of useful just to kind of see what's going on within the for loop before we run it, make sure it's doing what we want it to do. Now we can comment this out because we don't really need it anymore. And let's start over. So we'll reassign the vector all zeros. We'll assign the first two elements to be 1. And then we'll run the for loop and then look at the Fibonacci sequence. All right. Make sure you understand what's going on here. Hopefully this all makes sense. This is just a basic introduction to the syntax of for loops. It's super powerful. You can do so much with for loops. It really pays to really understand this construct. Before we move on to using the apply function as a more efficient way to do iteration in R, let's just show how powerful for loops can be. So, like we said, generating the first 10, elements of the Fibonacci sequence, we could do it ourselves, but let's add a couple zeros there and rerun it. You have to rerun all the way from here. So we've specified this x vector, that is the storage vector, with 1,000 elements now. And we still assign the first 2 elements to be 1, and let's iterate through it. Of course, it takes no time at all. The computer is so good at iterating. And now we have the first 1,000 elements of the Fibonacci sequence. Of course, we're starting to use scientific notation because it gets really big, really fast. So there we go, 1,000 elements of the Fibonacci sequence. That quickly, for loops, incredibly powerful. All right. Now, I like to start off with for loops, even in R. Now, you'll read forums, you'll read advice or blog posts saying that, telling you not to use for loops in R. Now, there's a good reason for that, because we have a more efficient way to do iteration in R called apply, which is very specific to R. For loops are general to any programming language pretty much. So it's still really important to know how to use them, plus they're more general. So I would definitely recommend really getting a hang of for loops before you move on to apply. But it's important in R to know how to use apply as well, partially because you'll see it all the time in other people's code, and mainly because it's more efficient than running for loops. And it's because R is a kind of a high-level programming language, and when you use apply, it's more efficient because it's kind of using the computer's memory in a more efficient way and able to run the same kind of iterations a lot faster. So so feel free to pause if you want to go over for loops again, but we're gonna go over apply at this point. All right. So to illustrate the use of apply for iteration, we're going to first specify a matrix. So we're going to make a matrix. The matrix is going to have these 4 elements. So it's going to have 4 elements that are randomly drawn from a Poisson distribution, and the Poisson distribution has a mean of 10. So that's what we're doing. We're taking 4 random numbers generated out of a Poisson distribution with a mean of 10. It'll look different every time, but we're going to assign that into a matrix that has 2 rows and 2 columns. All right, and that matrix is going to be named W, so it looks something like this. All right. Now what we're going to do is we're going to calculate the means of each row. All right. So in this line here, what we're going to do is for every row in the matrix W, we're going to take the mean of each row. What this 1 means is we're going to summarize across the first dimension of this matrix W, which happens to be the row. So we're going to take the matrix W, we're going to summarize across row, and the function we're going to use to summarize across row is the mean. So let's try that. So we take the matrix W, which remember is just Poisson deviates put together in a 2x2 matrix. We're going to take the rows, each row, and take the mean of each row. All right? And that's what we see happens to be 11.5 in both cases. But if I were to make that matrix again, it'll be something different because it is randomly generated. We can do the same thing with columns. If instead of 1, we specify the second dimension of the matrix, which happens to be the columns. So that's just the way matrices are specified in most programming languages. The first element of, when you're referencing the matrix. Let's see, when we say W, the first number before the comma here is the row, and the second one is the column. So that's, the row is the first dimension, the column is the second dimension. So that's why 1 references or summarizes across row, 2 summarizes across column. And again, we're going to just take the means. So the column means are 13 and 11 in this case. You'll get something different. Now, let's do this with 3 by 3, just to illustrate that we can do this obviously with much more complex matrices. So we're going to take a 3 by 3 matrix, again, just by taking random Poisson deviates, and we can calculate the row means and the column means. All right. Now, of course, we don't have to use the mean. We could use any function. We could use our own function, and we'll show that in a second. But we can also use other functions within base R, such as which max. Now, before we do that, we haven't seen which max before. So which max is a function in base R, which takes a vector. So let's say the vector is 3, 10, 5, or 2, 5, and 6. And it's going to take that vector and specify which element is the maximum. So we see that 10 is the maximum, 10 is the second element in that vector, so this should return 2. So that's what which max does. It just says which is the index of the element that has the highest value in a vector. So let's apply that to each row. So we're going to take W, and for every row, that is the first dimension, we're going to summarize, and we're going to say which element is the largest. Well, so it should be 3 is the largest element, is the index of the largest element in the first row. 3 is the index of the largest element in the second row, and 1 is the largest element here. And yours is going to be different because it's randomly generated, but we have 3, 3, and 1. So we can apply any function we want, including functions that we make ourselves. So let's make a function and then apply that function to each row of the matrix W. And this function is going to be complicated for no reason except that it's complicated. Because just to illustrate that you can do anything. So here's a function. We're going to train R to know how to do this thing called myfunc. And it means you're going to take a generic vector. We're going to, within function land, we're going to call that x. And so whatever vector we give it as input is going to be called x temporarily. And then we're going to do this stuff to x and return that value. So we're going to take 2 plus the sum of x divided by 5 minus 3 divided by 2 times, it doesn't matter, but you might want to put parentheses, if you really were to specify this function, because it's a little bit ambiguous what the order of operations you want here really is. So not perfectly specified. I would do better at using parentheses if I were actually creating this function from scratch and this mattered. But since it doesn't matter, whatever. So let's specify the function. So now we have this function myfunc. And my global environment's getting a little bit cluttered here, so it might be a good idea to just clear it. You can use this broom icon in RStudio to remove everything from your environment. We've already seen other ways to do that, but there you go. So now let's re-specify W. So now we have a matrix W in there, and let's re-specify myfunc. And now we can apply my function, myfunc, to this every row of the matrix W. And there we go. We get these values, which is this transformation for every row, but whatever. The point is you can specify whatever function you'd like to summarize across row. So the apply function just gives us the ability to summarize matrices, arrays across different dimensions and apply some function, some generic function across each row or column or whatever to summarize, all right? So it's a way to iterate across rows or across columns of an existing structured data object like a matrix. You can do it with data frames as well. So W could be a data frame, and it would work the same way. You could summarize across rows, you can summarize across columns. All right, now that's apply, but an apply function that's even more analogous to a for loop and that you'll probably see even more than apply itself is the lapply and sapply functions. These, we'll start with lapply, which stands for apply a function across a list. So L is for list. It means that we're going to take a list or a vector, and we're going to apply for every element in the list or vector that we give it as input. We're going to iterate across that vector just like we do in a for loop. So we're going to take, this value 1, then we're going to do the value 2, all the way to the end of this vector or list. And for every one of those elements, we're going to apply this function. All right. So this is, you'll see, somewhat similar to a for loop, but just know that this construct, these apply functions, are more efficient than for loops are in R. So let's see what this does. So this is going to take this iteration vector, and we're going to apply a function across this vector. Now, this is a little bit different from the way we have seen it, seen functions specified. So previously, we had something like, we would just say mean, so we could do that. It's asking for a function here. So we're going to take this vector and we're going to apply some function. Now, we could define a function in advance. We could use a base R function like mean. We could define the function in advance like we did here. Let's just take this out of this, and we can define this outside the apply function. So we could say my new func is going to be defined as just take the e to to some power, right? So we could define my new func and then put that right here, and that's going to take e to the power of 1, e to the power of 2, e to the power of 3, so on and so forth, and it's going to return that as a list. So for every time, and that's what lapply does, it's going to return a list, and one list element for every iteration here. So it's going to be 5 list elements here because there were 5 elements in this vector, and each time it's going to take whatever this iteration vector was, and it's going to take e to that power and return that. So that's what lapply does in this case. Now, the way you'll often see it in R code is instead of defining that function in advance, you just put the function right into the apply statement. So we're going to define the function right within our apply function itself, and that's the way we can do it. So we're going to take this vector, and for every element of that vector, we're going to both define this function and run that function. So that's what this syntax means, all right? So it does the exact same thing as we just did, but with one fewer line of code. So you'll see that a lot. So let's take another example. Here, we're going to do something a little more complicated. For every element of this vector, we're going to dig into the trees data set. So trees data set with the volume column. So just a vector, numeric vector, that specifies the volume of each of these black cherry trees, I think. And then we're going to take the square root. So first of all, for the first time we iterate through this apply loop, the vector, the value x is going to be assigned 1, And so we're going to take the first element. So x is going to be 1. So we're going to take the first element of this, which should be 10.3. And then we'll take the square root of that. And that's what's going to be the first list element that's returned from this lapply call. Then this value x, or whatever we assign the function input to be, is going to take the value 2. And then we're going to take the second element of the volume vector, take the square root of that, and that's going to be the second element of the list. So basically, we're going to take the first 5 elements of the volume from the tree's built-in data set, and we're going to take the square root of that. All right, so that's what we're doing here, and that's what we get. So you can verify to yourself that that's what it's doing. It's a good idea to maybe pause the video and make sure you understand what's going on. But it's very similar to a for loop, and essentially you can accomplish almost everything that you would accomplish with a for loop. You could use apply for. It's not always the case, but in many cases, especially for simple iterations, you can accomplish that, and it's going to be more efficient. So again, one last time, you can specify a function that takes an input. Now, lapply is going to go through every element of what you give it in this first argument. So it's gonna, if it takes a vector, it might take a list. You can iterate through anything that you essentially provide here. And for every one of those, it's going to take this 1, and it's going to apply a function to it. So it's going to use that 1 as the input for whatever function you give it. All right? Here we're giving it a function that takes an input called x. And so basically, the first time in the apply loop, it's going to assign this value x to be 1. Then it's going to assign this value x to be the next value in this vector, which is 2, and then 3, and then 4, and then 5. And so it's going to iterate 5 times. It's going to return 5 list elements. And each time, it's going to assign the value x to be, 1, start off with 1, then 2, then 3. And so in this case, it's going to take the first element of the volume vector, then the second, then the third, then the fourth, and it's going to take the square root each time, and that's what it returns. So make sure you understand how that works. It takes a little bit of time to really internalize how to use the apply statements. And if you're confused, don't worry. Stick with for loops until the apply statements make sense. All right? There's no shame in using for loops. Don't let internet bloggers and other posts like shame you into trying to use apply when you really don't understand how to use apply. Make sure the first thing is that you understand what you're doing in programming in general. Don't worry about efficiency. Just make something that works. Then the next stage in programming really is getting more efficient and maybe moving over to apply functions. So don't feel bad if you don't use apply functions right away. You can use for loops, and in a way that is, the language of for loops is something that all programmers use. Apply is very particular to R, so learning for loops is really useful anyway. So again, go ahead and use for loops. You have permission. One last, actually, there's 2 more apply variants that I wanted to briefly touch on here. So we have the sapply, which you can think of very similarly to lapply. It's basically a wrapper around lapply that takes the results, which lapply always gives you a list in the end. Sometimes you don't want a list. Like, that adds extra complexity here. Maybe I just want a vector with the first element, 3.209, so on and so forth. Maybe I don't want a list. I just want a simple vector returned. So what I could do is do sapply, which S stands for simplified lapply. Basically, it's a simple, it simplifies the output or the results from the operation. So remember when we used lapply and we took e to the power of whatever the input vector told us to use as input. So it'll be e to the 1, e to the 2, e to the 3, e to the 4, and e to the 5 as we go through this iteration vector or list. So lapply returned a list, sapply will return a simplified vector. So just convenient. You'll see this a lot, used a lot in R. All right, that's all I'll say about that simplified version of lapply. tapply is another one you'll see. In fact, we've seen tapply once before in this bootcamp, and what tapply does is it takes two vectors as input. One vector to specify, say, just well, let's show you what it's doing. It's easier in an example than if I just try to explain in a generic way. So we're going to define a data frame. The data frame is going to have 10 rows. It's going to have 2 columns. The first column is called var1, and it's just random uniform numbers between 0 and 1, and it's going to be 10 of those random numbers. And the second one is going to be called group, and it's going to have the values A or B, so it has 2 possibilities, and we're just going to sample from these 2 possibilities 10 times randomly with replacement. And so we'll get some random combination of A's and B's. And so if we look at df new, this is our new data frame with random numbers for this variable, some measurement we might be taking, and this is a group or treatment that we might, we can imagine this is just a sort of made-up experiment. So what we're going to want to do here is to summarize the var1 for the group B and summarize var1 for the group A. So we're going to first split up this vector, this var1 vector, into 2 groups, one representing all the B's and one representing all the A's. And then we're going to apply some function to each group. And that function is whatever we specify in the tapply function. In this case, we're just going to take the sum of var1 for each group. So the first thing you specify in tapply is the variable you want to summarize. Then you specify the groupings that you want to make within var1. So you want to summarize across groups. So you're going to split up var1 by group. So we're going to take all the B's, take all the A's, and summarize var1. And we can summarize it any way we want. We could specify our own function, but we're going to, in this case, take the sum, and that's, oh, sorry. And it looks like that. So this is the sum of var1 of all observations that are classified as group A, and this is the same for group B. So a useful construct every time you want to group some variable according to some other variable that defines that can define a group. So some factor variable, essentially, some variable that has, it's categorical, it has names, and you can use that to summarize some other quantitative variable. That's when you use something like tapply. And if you are familiar, later in this bootcamp, we'll go through ways to do the same thing, but using the popular tidyverse package or set of packages. So a lot of people are using the tidyverse to do this type of operation instead of base R, but I still think it's really important to understand that you can do a lot of this stuff using base R without loading any additional packages and stuff. So it's kind of useful to have that in your back pocket anyway. All right. So that is, in terms of content, that's where we want to get to in this programming video. We have a few practice exercises that we can walk through, and I'll walk through that in the next video, which will be the final video for the first bootcamp. And then that's followed by some challenge problems, which I won't walk you through, so you can do them on your own. But take a minute before watching the next video to try to work through these practice exercises yourself, and then we can work through them together in the next video. But I think you'll gain a lot more out of this if you try yourself first. All right, I'll see you in the next video.